Now let's talk about reaction with BH3 THF. This is also a reduction reaction. So this is called boron hydride or borane. And it's called boron hydride or borane. So how does it react as a reducing agent? Its structure, first of all, look at its structure. It has this type of structure, and we have a empty p orbital over here. We all know that it has empty p orbital. So it gives electrophilic. It is an electrophilic reagent. It is an electrophilic. So how does it react? Let's check its reaction with aldehyde first. With aldehydes. With aldehyde, it RC double bond OH. BH3 will react first BH3 with tetrahydrofurane. Second is H2O. It will form RCH2OH. It will reduce it. Now how will it reduce? Let's look at its mechanism. First of all, we have RC double bond OH. We have boron, hydrogen, hydrogen, and hydrogen. Now this carbon will absorb hydrogen and oxygen will attach to the boron. So the intermediate will form RCHO, hydrogen, boron, hydrogen, hydrogen. Then it will form RCHOBH2. Now when it will hydrolyze, hydrogen will be there, OH will be there. So it will form RCH2OH plus BOH, H and H. That's how it will form H3BO. Okay, this compound will form. So let's solve the questions of with aldehyde with BH3 THF. First we have aldehyde. First it will be BD3 and THF. Second H2. It will form RCH. Deuterium will add here oxygen with hydrogen. Because the oxygen hydrogen will come from water and the carbon deuterium comes from BD3. Second we have RC double bond OH. It will react with BT3 THF. Second H2. Again similar type of reaction RCHTOH. Now next question we have an aldehyde. First it will react with BH3 THF. Second D2O. So it will form COH, hydrogen and hydrogen. This compound will form. Now let's look at its reaction with ketones. BH3 reacts second with ketone. So how does it react with ketone? Let's say we have a ketone. So we will be reacting BH3 THF. Tetrahydrofurane we use because it has high boiling point. So it will form HO and H. A similar type of mechanism we follow. Let's say it is reacting with same compound. First BD3 THF. Second is H2O. So it will DONH. This compound, a similar reaction we have seen. Acid halide. Let's look at its third reaction with acid halide. How does it react with acid halide? So in this reaction, acid halide, we have RC double bond O Cl. When react with BH3 and THF, nope, no reactions. Why don't it reacts? Because actually BH3 is what? Electrophile. It is electrophile and attracts towards electron because it is only 6 electron in its outermost shell. And we have RC double bond O Cl. So first it was attacking to BH. That's how it used to attack first. But what happens? Chlorine pulls all the electron density towards it. Chlorine pulls all the electron density. So let's draw it above. So it is easy to understand. We have chlorine. Chlorine pulls all the electron density, so it don't get sufficient. Don't get sufficient electron density now. So it will not react. It won't get insufficient electron density on oxygen now, because chlorine pulls all the electron density, so boron will not get electron density, so it won't attack. Let's talk about that. Is ester. Ester, we have R C double bond O O R1. It is showing plus M effect. So yes, it is increasing the electron density. It will react with BH3 THF to form aldehyde and R1OH. So if we compare the rate, let's do a very good problem. R C double bond OH, R C double bond O R, R C double bond O Cl, R C double bond O O R. If we compare the rate, let's say we have A, B, C and D. So when it reacts with LAH or BH3, what will be the rate with LAH? What will be the rate with BH3? So when we compare with LAH, the rate of the reaction will be highest in case of C, because C is actually intensify the charge. In LH we have to see where the delta positive is intensifying. So delta positive is intensifying when we have chlorine, because it is showing minus I. Okay, so first of all we have C, then it goes to A, because R is showing actually plus I and it is showing plus M. So all are increasing the electron density over here. So first of all we have C, then A, then B, then D, because D is having plus M effect over here, it is having minus I, it is having plus H, and it is having no effect. So more the electron pulling power, more will be the rate of the reaction with LAH, because it is acting as a nucleophile here and it is going on nucleophilic addition reaction. Now with BS3, highest will be which is increasing electron density to that carbonyl part, which is increasing electron density to that part will be highest for B. So it will be D, then B, then A, and it won't react even with C. We have seen it doesn't react with C. And why after B we have D, we have B? So what happens when we have R and H? So R is actually pushing tendency plus H effect, or we can say plus I effect is showing. So it is increasing electron density to the double bond as compared to H. So B has more rate with BH3. So that's how we check the rate of LIH and BH3. Both are different, but both are reducing agent. Okay, we are checking rate of the reaction. Rate of reaction. Now let's check some more question. We have carboxylic acid. Carboxylic acid, first it react with BH3 and THF. B it react with H2O. So it forms aldehyde. Then further react CH2OH ketone. R C double bond O O C double bond O R. First it will react BH3 THF. Second H2. It will form 2R CH2OH. Third we have RC triple bond N, cyanide. When it reacts with BH3 and THF, it forms RCH double bond NH. Further reducing, it forms RCH2 NH2. All the mechanisms are same. It gets absorbs and bond breaks. All the things are same. Let's look at fourth reaction. We have with amine RC double bond O NH2. First it will react with BH3 and THF. It will form RCH2 NH2. This type of amine BH3 and THF, it will form H and H. This compound will form. It will reduce the double bond. Or every time it is reducing all the oxygen or double bond. With alkane and alkene. Alkane, we can say alkane. RCH double bond CH2. First it will react with BH3 and THF. Second CH3COOH. It will form RCH2CH3. Similar with alkyne also. We will react the reaction with alkyne. We have RC triple bond CH. First it will react with BH3 and THF. Second we have acetic acid to give the H plus only. So RCH double bond CH2, which will convert to RCH2 and CH3. So that's how we have seen the reaction of H2 with BH3 and THF.